Record to. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers or where all the time in your life goes when you're just trying to get shit done. And anything and everything in between, in theory, language implementation, compiler design, and stuff. I don't typically have a set agenda. Conversation goes where it goes. We all show up on YouTube in a couple hours. Okay, that's the starting spiel. Um, If somebody's really excited, they can start. Otherwise, I'm going to do a week in review of what happened with Simple and my lawn. The lawn's easy. It's just way out of control, and it needs a much heavier duty piece of equipment. I have a medium duty weed whacker, and my neighbor showed up with a monstrous lawnmower-ish bushwhacker that did the job, and my weed whacker was just not going to cut it. Um, Fine. Simple,
Wait,
yeah.
did you just say your weed whacker is just not going to cut it?
Exactly.
That was
Sorry,
awfully
you have to face facts sometimes. My tool is not up to the job. Just is what it is. It's actually a fairly new tool too. I bought it to go up the mountains. I thought, oh, okay, this will be easy. I'll trim off the edges. I'll clean off the, bits and pieces here and there. No, 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 not remotely close. Now you've lost my train of thought. Here we go. Da, 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 da. I'm going to attempt to share. And we have, oh, Zoom, you're not helpful. There you go. Okay, so we have here is, what did I do in Simple this week? So I did a bunch of things. Um, I was trying to get to having strings going, and I thought I would not do all of strings right away and just do all the parts that need to happen to make strings happen. So there's a couple things. I decided I wanted an easier way to get at libc. So we're linking against libc. So I wanted some way to get to an import notion. So here's sys as my one import that covers everything, maybe. Um, the comment line is so Emacs knows that simple file should use Java's color coding scheme. And so here is, go get a libc call, right? File descriptor one, some string, and the length of the string. So it's a classic libc write. This is the goal for the week, to make this print out hello world. Um, so then I needed a sys.libc. That's a nested type. I don't have nested types. Well, I do now. So part of the week was getting nested types in. Um, and I don't claim they're super well tested. But theory says I know I can make fields inside of sys as well as in libc, which I make right here. So there's a thing with nested types that they can now be declared and used. There's nothing about inner classes or the inside of a struct points to the outer sys or anything. These are all static classes with name scopes. Then this is a function declaration a la normal simple code with a variable who is finally assigned quote C quote. That's my syntax for it's an external C call. So I have FFI. Yeah, I'm getting there. That shows up down here as a constant array. So up till now, well, so let's finish off libc here. So um, I can make FFI calls. I've been able to do that for a little while because all the new operations go to calloc right now. So I'm linking against libc and there's no free. So, you got the alpha collector, the epsilon collector, you allocate to die. But there it is. This will link against the right against C. I know it shows up in the ELF file. I haven't got everything else going, so it doesn't actually call with correct arguments, so it just crashes. So, okay, but progress. Then I've not had constant arrays. So I'm looking for a syntax to declare an array to be constant. I'm happy to take discussions that this is a bad syntax. I needed something quick and I wanted to move on, and it's easy to change exactly how the syntax is. I had a bunch of other fish to fry, so I picked a random bad syntax and moved on. If somebody wants to pop in and say, this means something. So like, here is things that show up that you can and can't do with constant arrays. Um, If I make a uint array, new u8 of 10, how do I fill this buffer in? Oops, I got to put a new one in. How do I fill this buffer in if it's if it's an final constant? So by default, arrays are initialized as mutable. At some future date, I'm going to pick up some Cameron ecstasy love and throw down a function here so you can initialize an array and immediately declare it mutable in constant in one step. I don't have that right now.
So you know Java's actually adding the same thing now.
Oh my God, you've had a real impact in the world,
The
sir.
same exact ecstasy syntax, which I don't know if it's a coincidence or not, but I'm so happy to see it.
Yes,
Java's
yes.
Java's
I have
adding immutable arrays.
immutable. Yeah,
Oh, no, but they're adding the ability to put a
A
lambda.
function to initialize them.
yeah,
Yep,
yeah. Initialize it.
Okay,
yep.
nice.
Very, very cool.
So this would be something like, and then you have a lambda here. It takes an index and it produces something, whatever index times two. There fills the numbers from 0 to 10, double, whatever, right? You put a lambda there. And then you could declare it immutable from the start, and I didn't have any syntax for that. Directly, I have indirectly syntax for that. I can say val. Val will do type inferencing, except that the end result is immutable. So this one works.
So how do you differentiate between the immutable array and the immutable variable named buff? Because the
Yes,
one says that I have a pointer which I can't change, and the other says the thing that the pointer points to can't change. And if we learned anything from C, having those two different things using the same exact syntax ends up being
right. So
a
value
mess.
makes buff deeply immutable. So buff is immutable and value and the contents are immutable. If I want buff alone to be immutable, actually this is by default immutable. So here the buff is immutable. Let's do this one. No, no, don't scroll. What the hell? Um, so that's that version. If I say var, it's deeply mutable. If I say U8 of bracket of bang buff equals, that makes buff mutable, and by default, arrays are mutable. New U8, blah, blah, blah. This is also deeply mutable. So I don't have a way to say make it immutable, and now I do. So this would be this syntax. Well, this syntax, beg your pardon. And now it's not deeply mutable. It's buff mutable, buff is immutable. So better have some way to initialize it or you get a pile of zeros. And then you can argue left and right about what to do there. So the easy one is I make a copy of buff. So var buff equals new u8 of, len. And then I initialize it with my old syntax. And then, buff pound I plus plus, and, buff of I equals I times I. Here's your array of squares. But then I want to pass it off to somebody where well, then I want to make a version of it that's immutable. So say val buff equals buff. Okay, now I'm going to call this buff two, so I don't have named issues. Okay, now it's buff two is deeply immutable. And then I can hand off buff two to somebody else. And if I keep buff around, then I have a mutable and immutable references to the same backing array. And the person who has buff two isn't allowed to change it, but a person who has buff is allowed to change it. So if you're looking for some sort of safety thing, you would toss away your buff and say, I don't got it no more. So the only thing that exists is the immutable version.
So you're doing that as a feature, not a bug.
Yes. Tell
So
me this is bad.
So that would mean immutable reference, no copy. both they would hold a reference to both,
So
but
right
not a copy.
now, this is a reference copy, so they share the backing memory.
See, I wouldn't say it's bad.
Yeah.
It's potentially bad, right? Because it matters about the overall design. Like, is that a useful thing that you want to leverage versus something that's going to prevent you from optimizing based on immutability later?
Um, so there's another typing thing that I'm not tracking at the moment that we could go to, which is to say that the contents are deeply immutable for all, as opposed to deeply immutable for me. So if I make a deeply immutable buff and I hand it off to you, you'll only be able to take it if you promise that you can't mutate, you won't mutate. So the caller knows that the callee can't change it. So
That's
if
like
I call
taking
foo of buff two, this code knows that foo cannot change
that's
buffs.
like borrowing immutable reference in Rust lingo, I think.
I don't know. I don't want to use the word borrow until I have memory
Okay,
management and
so
Rust sorted
you
out because there's a
you
naming
take an
convention.
immutable reference and you cannot change the contents of the array.
Oh, okay. That is pretty much spot on. Yeah, yeah.
I
You
mean,
are,
that's
you
just
are
immutability, right? I mean, any functional programming language has that by default.
right.
I wouldn't bring borrowing into that. It has
Okay,
nothing to do with past. It's just immutability.
back off, scratch that, no borrowing. So just immutable reference.
Right.
What's interesting about it though is that he still has a mutable reference. Sorry, let me be
Yeah.
more verbally clear.
Yeah.
So
A's mutable.
if you pass buff, what will happen to foo? What will happen to the parameter of foo?
Well, that's the thing. It's an aliasing. In
Yeah.
some languages, this is considered an aliasing nightmare,
Hmm.
but it's also a useful capability if it's something you're designing for. So I'm not going to say it's bad or good. It's just potentially bad and potentially good.
I'm not against it per se, but whatever you do with buff two, it's constantly in danger if you change the contents of buff and you to beneath
Th-
you the buff two would be
Yeah.
changed.
This is the case where I'm going to give you enough rope to hang yourself.
Mm.
If you
So
throw away
that's
buff,
the C++ model, I would assume, right?
right.
It's as const as you want to avoid casting away.
Well, I don't allow you to cast away. So it's a little stronger than C++. There is no cast away, but there is a second unaliased, and you could pass them both along. You could put both versions somewhere, and then somebody could use the mutable version to update, and then the immutable version changes.
Right. And the benefit of that is that the immutability has nothing to do with the memory itself. It has to do
Mm.
with the thing you get that would allow you to see the memory.
Suppose I
But
have a database cache access mechanism, and readers go hit the cache all the time. From their point of view, the database cache is immutable, and I can tell them that's immutable, and they can get a deeply immutable thing, and they can't modify it.
why the long syntax? Why can't what was the bang immutable? So you
Okay,
modify
the bang is on a variable declaration. You have an
so
expression that you're putting the bang on.
yeah
That's not syntax.
so okay
Yeah,
so
the
can you
bang is strictly for I'm going to take the bang away because it's not valid syntax for anything.
okay
But the bang is on variable declarations to say that the
yeah
variable can be modified.
okay.
So this version up here that says bang buff, I
Mm.
could, in theory, just write some more code. It says buff is equal to, another array, a brand
Mhm.
new one.
Mm.
It's mutable.
That's one thing I actually hate about C++, and what I hate about this syntax is that you are making immutability special and annotating this with an exclamation, even though that should be the default. I would
So,
flip the defaults here.
okay, so I hear you, and I heard you do this before, and I think we were confused. This buff is immutable. The default is for variables to be immutable, with the sole exception of arrays, which if I make them immutable from the start, you can't modify the contents of the array. So it's always only ever filled with whatever default crap it got when it was allocated. So buff here, when I've highlighted the buff, that is immutable. The contents of buff is defaults to mutable. This is
Yeah, I
not
hate that
true for.
distinction too.
I'm sorry.
I hate that distinction too, because it kind of mirrors C when you don't really have arrays, but you have something that decays to a pointer, and then even though you say that's constant, it's just the pointer that's constant, but you can modify the array. I actually absolutely hate that distinction too.
Yeah, well,
I just that just
I'm here stuck for the same reason. Sometimes you can do this version, lambda to init, and then I could have picked a different syntax here to make it deeply immutable after the lambda. So lambda runs, constructs, and then it's deeply immutable. That syntax is very simple. I just say val. I say this one, this guy. Val is deeply immutable. Or if I put my squirrely bracket, my twiddle in the middle, it will also be deeply immutable.
The
And it
question
gets
is, for
initialized to something.
example, that's kind of like what Cameron said with this. How does it go with the overall design? Say you add classes at some point and you allowed users to write collections, and they're gonna write their own collection that mirrors an array. Are they gonna have the same split between the mutable reference like
Yeah,
handle and
I was
then
exactly trying to
mutable
pull that.
contents?
I was exactly trying to pull that example out
Mhm.
verbally, but yes, nearly all collections are backed by a mutable array. Nearly all collections don't want anyone else messing with that array, but they want some fast, cheap way for people to access the contents of the array. So a reasonable approach would be to say this array, when viewed from the outside, is immutable and people can read it freely as an array, but they can't write it. But I have, internal secret knowledge that lets me mutate that array, which I'll mutate it via accessors that preserve the collection properties. That would be a design goal here. So I
What
don't
about
have an instance of that lying around, so I can fake one on the fly, but it'll just be faked on the fly. Struct, I don't want to say array, think array list here. And I want to have an array that's inside. I want it private to me because I can hand out the mutable version with the getter. So I want an int array. It's a collection of ints here, which is going to be my buff, new int. I'll give it initial length here. I'm going to have an int, whatever, length, which is my capacity, which if I don't initialize comes to 0. And then I have to have rules about private and public. Currently, I don't have them, but I'll probably have something along the lines of if you're underscore your private. And then I might change the defaults to say immutable or not. Otherwise, I'm going to pretend these are both all deeply mutable. And then I want to say, oh, I'm going to hand you out the buff, and you can go call it as a function. Takes no args and returns me under buff. Okay, so here is a version where the user can call buff. So make an array. So I have an array. It's my array. It's new array. Okay, I have one. And I want to say array.buff. Okay, I have the array of ints. And can I do something with it? Well, since I got the bare array, I can ask for 99. That'll give me a runtime array out of bounds exception. But I could say, give me array element 0 or anything I want here. So it's not necessarily what I want because it doesn't do the internal length array check, but I can get the contents of buff as a immutable thing, which means I cannot do this. Immutable, right? But obviously I want an add of, I have to add an add call in here. And I don't know what add's going to return for the moment. So let's just say it returns the element you just added. It's probably not the right answer. Some element E, and then there's going to be some range check in here. And, if length equals buff length, I have to do a range check thing and expand the array. Otherwise, buff of len plus plus equals E, and that's the return as well. So I can put a return here or not. Return keyword's optional. You just always get the last expression. So there is, returning. There is a thing which, more or less puts an add on. We're missing how expansion works, but it's
So I would count this as a mutation. I mean, the way to check this is basically if I now told this add concurrently, is this safe or not? If it's unsafe, then that's something I think should be annotated with the exclamation mark.
okay. So I'm not doing any threads. I'm not doing any multi-threading
Yeah,
here.
yeah, I'm just talking about as a general design principle. Just imagine you were adding threads. What should be the default? What is safe
Yeah.
by default? What could possibly be unsafe?
Well,
And
the first thing for
because
the
the
default,
mutation could be unsafe, I would annotate the mutation with the exclamation mark.
I
Because
would say
that's
the first
something,
thing that happens when I add multiple threads is that everyone defaults to being thread local unless you ask for multi-threaded shared. So you start with, you just can't get access from another thread, period, end of statement. Now, if you want to say this structure is multi-threaded sharing, as every shared concurrent hash table and every cache everywhere on the planet ever does, you need to mark it as this is a sharing thing, and now you're going to change how the rules work. And it may be a bunch of defaults change as well. I don't know. So I haven't thought through what it means to be multi-threaded sharing other than to say the default is no.
yeah, that sounds reasonable, but I would think about this at the same moment as I think about mutation. This maybe the hard
I know,
experience
but
in
I
concurrent
got too many things
programming.
in the air at once. So I've decided I'm going to
Fair
punt
enough.
and then I'll revisit this when it's time to do multi-threading.
Fair enough.
And then whoever's hacking the code, you probably can select it all and declare it Java-ish, and it will color
Mm.
code.
Mm.
I'll go up here under tools or extensions, add-on, code box. Start, yes, working, code box to
I
the
was
right,
about to say
pointers.
it
There's
defaults
some,
to
yeah, color
Java.
coding, cut and paste maneuver can be done over there.
Okay.
So yes, so the thing that I didn't have at the start of the week was any way to declare an array immutable, especially on function arguments where I wanted to demand that I could hand a guy an immutable array and have him be, compiler spec forced immutable. And of course, write doesn't modify the array, and I couldn't hand him an immutable array because I couldn't declare it. So when I made my first immutable array, I got a type error saying, you can't pass this to write, write will mutate it, which was what I wanted, except I didn't want to have that. So that was one of the things that happened this week. There was this syntax, which makes me an immutable array of U8s of length 13, and the compiler internally carries the metadata that knows its length 13. And I got as far as it's in the typing, it goes to the constant pool generator, and I'm now in the middle of changing the constant pool, which previously was only dealing with single entities whose log size was equal to their alignment. So 1 byte, 2 byte, 4 byte, 8 byte things. Wow, that color coded weird. It's fine.
I don't know what happened.
Yeah, I found the code blocks to be kind of flaky, but when it worked, it was great. Fine. So this turns into I need to have a constant pool. Which is written out into the ELF file as the constant pool section of the ELF file, which is busy, which is where I'm at with the coding, where I say, what is the log size of hello world? Well, the answer is it's not defined well, not well defined. So wait a second. What's the alignment? So everyone who did log size changes and they have log size and alignment as separate things, and structs have collections of things that have to do alignment to max alignment of their contents. And hello world needs 1 byte alignment, but an array with a length of size whatever needs 4 byte alignment because the length field is 4 bytes at the moment. That's being worked on as well. And then the Zemelia is not here, but his fuzzer finds a low frequency steady stream of minor bugs. I did a reset hack to improve on one particular people, and the fuzzer is sort of dribbling in missed tests, missed safety checks on me. Let me go back to GitHub and see if I have anything else. So I've added a x86 large constant pointer node, which produces and encodes out to being load an address from the constant pool, which will point to the hello world string, obviously, which changed the x86 instruction selector to deal with that. I parse the sys.libc syntax before I parse your main function. And so because it's simple code, I can just add another binding literally by editing the file, and now I have a new binding. So the theory is I can add a whole lot of bindings really quickly. There is the static field lookup. Oh, that's the other thing I did. Where did it go? Come back. You're hacking. I'm going to scroll to here. So this is a constant final field. And so I've picked up on any struct who has a constant final field in the constructor, not in the well, in the declaration, not the constructor, the declaration. You have a constant final field in the declaration. It will be moved aside as essentially a global static variable. It's like a static variable in the Java. It's just namespace things for static globals. And because it's a function, it is a field. You can reference the field directly, and I do in the code. I do a field lookup on a constant type field with a constant value, and I get a constant function out of it, which I can then inline as the call. But it's a total field lookup. It doesn't have to be functions there. I can put values for pi and a string for the name of your OS and the number of CPUs and your proc info kind of stuff as constants that would show up in the constant pool and the process start. So there's a plan there for, I'm heading down the road of methods and classes. And the word struct may change to the word class at some day because it's going to get closer to classes. As far as I'm thinking in my head, I'm not a class until I have single inheritance. But maybe I should be a class as soon as I have methods. I don't know. Why? Does anyone care what the name class or struct means? No, immutability matters. People got excited about immutability.
Unless struct turns into records, into not
Yeah, well,
class.
then the Java version of a record means that everything's constant after construction. It's not it's immutable after construction, which is my default. Let me scroll down here, and I mean, you know, you get these things. Struct s has a field. It's called a string field, name, and it has a int age and int whatever, you know, salary. I don't care. I can't type.
And I mean that you will pass that by value, or do you care? I don't know.
Oh, coming along is going to be by value structs. That's in the plan. And I have a syntax picked out for it. It'll be the star, which we pronounced contents of. And then you can inline structs inside of structs, and you can have inline structs and arrays, so they don't have any headers, so you get the compacted version of things, and so on and so forth. And the sort of the general rule there is if you have a by contents of, you don't have a memory identifier, you don't have a reference. So you can take a reference and make it a value by doing contents of, but you cannot take a value and make it a reference without first allocating a pointer somewhere, having a pointer somewhere. And those are just straightforward rules on, I think I wrote a bunch about that in the README on
So
chapter
what
20.
would be, just a side question, what would be the semantics of by value? So all the contents of the struct will be in registers, or I don't know.
Yeah, hang on. I have a long discussion. I'm trying to decide where the README in chapter 22 has a bunch of this stuff. I could change to trying to find the right place to bring this up here. Structs can be inline. Okay, let me change. Are we done with this for the moment here? I was going to show an example. This is like immutable by default, and you can ask for mutable. I'm not there, so let me stop. Okay, yeah. Zoom helpfully pops the stop share button, scrolling it from hidden away to down the screen underneath other windows. You can see it slide by, but you can't actually click on it. Okay, Zoom, whatever. No, no Zoom, don't intercept. Oh my God. Zoom is, oh, there it goes. Zoom is trying to intercept Emacs's keystrokes to increase the font. I think one more. Yeah, that's right. There you go. Okay, so structs can be inline. What am I doing here? Normally by reference, turned by value, by putting the star, meaning contents of. Maybe I'll change the name later. I don't know. So here is a struct complex. It has two fields, X and Y. It has a method called length. I can make a by reference version where I have a pointer struct. And then if I want to print it and I make it by reference, I do .c and then I do a .y from the .c, and that's a memory load to go from the by reference struct through the complex pointer to y. New behavior, I have a star complex that is an inline struct. The full size of it, that's two 8-byte floats, gets inline, so 16 bytes gets inline. And when I do the by value .c.y, I will not have an extra memory load. You'll get just the load from the base of the by value object to the y field, which has been inlined inside of the thing. So then you get this little mix. I'm going to resend. Whoops. What happened there? Oh, man. I see what happened there. Hang on. Try this. Let me try this a little bit. Okay. So here's the rules on conversion between the two. You can't mix in general refs and values. So you get an error here. I can take a value and store it over a ref with a star on the ref side, the left-hand side. That's a bulk assignment, whole structure copy. Can't go the reverse direction because you can't mix refs and values. But I can say, give me the contents, and now I have a whole structure copy. And then ref to ref C, that's just a pointer copy, and ref and val to val is a structure copy directly. Those are all allowed. And there's no notion of a contents of a value. It doesn't have a reference. There's no contents of. And we went back and forth on the syntax here. Here is I make an array of contents of complexes. So inline complex objects, no overhead for object headers or anything. I know from the name of the array, from the type of the array, that it's just full of complex objects, which is just X, Y pairs back to back to back to back to back. Calling methods all has the same syntax. I can put this signature thing on by value places. Actually, this probably needs to be here. So I can pass by value or by reference at your choice. And then, you know, here's that's the declaration, and here's the calling convention. So that answered the question?
Yeah.
Yeah. So that's all future work. It looks consistent. Don't know if you code in anger for a little bit. Yeah. I kind of sorted on README for a while, changed a bunch of the other READMEs. This piece of the README for chapter 22 is there. Like the whole, I make an ELF file with the write paw and the x86 encodings, so the RISC encodings to ARM, whatever, they get patched at load time like you'd expect. So that's working. And you can JIT and they'll get patched in memory as well. So I think that piece is there. I went back and forth on how to do importing namespaces. I currently have a thing where I just say you get sys by default, and sys will have whatever sys has, and right now it has libc. But it might have IO, and it might have printing, and it might have math utilities and other things at future dates. Unifying structs and arrays is coming. The implementation internally has been using struct for arrays for a while. I tried to do some other fancy things to get my string ABC to go out with the least amount of effort. and figured I'd just expand it later, and that was not even actually worth it. So I unwound a bunch of shit that I spent half the week on. And I'm back to I have a struct and array, but now I can allow a constant array. So the array of bytes here has a summary field, and it has a precise, this is the contents field if you have a constant array. And then it doesn't have to be characters, of course. You can have array of floats, an array of persons and complexes or whatever is constant things. And so these things all work right now on the normal fields. This particular struct has a hash as well. Under the theory, it's headed for being a string-like thing that has hash code that's cached. And that should work pretty readily, except I'll not let you declare this yet. But I think the internal structure is there to deal with it. And here is me making a vector int, so trying to write one on the fly. Same, other than the new bits coming, so I'm going to say you can have different sized array lengths. There'll be some basic integer, power of 2 integer sized holder, but it doesn't have to be a full 4 bytes. If you have tiny German strings, those come later. You can have 1 byte or sub-byte length fields. And here is a sample where I have a bogus class, community college class, not a other kind of class. And there's some fields up front that say things about whatever, and then there's an array of students. Yeah, fine. Or some self-recursive entry design where you have a 1 byte length. So the rule is just, if you're going to be fields and also an array, the array comes at the end. It has to be called this certain thing. There's a little bit different syntax for constructing such a thing because you want to initialize the fields and the array both. Like here, make me a new entry. The value is 17. That's the payload on this is an abstract int type structure, and the payload is that. But it has 2 other entry children's. Fine. Here is the discussion about what we just talked about. Make a new U8 whose size is length of some current buffer. Then copy from buffer into this thing where I uppercase every character. Yeah, or whatever. Take a lambda there. And then there's discussion about here's an array called struct, but it's an array where the length is limited to 0 to 255, or powers of 2 larger, and what are the rules for changing between them? Stuff like that. So this is all stuff I threw down for what I was trying to get a hold of in doing strings. And I got too many stuff, so I have to go trim the chapter again. I'm kind of trying to get to the point where I can say hello world in the 1 line of reasonable code. But a potential string would look like a bunch of fields that are, it says value, so it's a final, it's assigned to a function, so it's a constant. Final constant, you move off to the class field. It gets out of the name. It's not ever stored in the instances, it's stored off to the side. And then they do what they do. So this one adds a character, possibly growing, and this is the grow code. And then there's, somebody who called libc, me exploring with how I can go call libc here, my string, and then here is this particular string is the growable kind. This is a string builder. This is a Java string builder. And then there's a version that maybe everything's final. So here is one of my syntaxes was trailing bang, and I went instead for the twiddle in the middle. And I can make a string, and I can make maybe declare a safe string, which is one that is globally universally immutable. And it's just like has the same API as a string, except I might have to make a defensive copy so that you're not allowed to secretly hold on to a backing mutable array buffer, which is what
Just a minor note on the trailing bang. Since you're also using bang to mean mutable, it would be pretty confusing to make it mutable and immutable from the same character.
Right. It was like,
Although Perl would be proud of you.
exactly. Thank you. So I backed off from that one. I decided after a while, when I wrote the README and I edited and re-edited and blah, 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 and I came around along the way, I said, kind of that's stupid because it's the inverse of mutability. Well, what's the default? And you're inverting. No, don't do that. Make it mean mutable. But now it's no good. So I'll just edit it now.
But it was made mutable or immutable by having it be the trailing character. So that really is enough context.
I understand. And I'm like, Twitch,
Like I
with
said,
Cameron here.
I'm
like I
Twitch,
said,
Twitch.
Perl would be
I'm
proud.
kidding.
Thank you. Yeah.
Perfectly functional.
Extendable, mutable, Unicode just changes, maybe changes to hand you some Unicode iterator that does successive Unicode character.
Now that you mentioned Unicode, Spanish has this upside down exclamation mark.
Thank you. Your suggestion has been noted. Not ready to require the language. Maybe I might as well go to APL, right? You have to have, every kind of weird Greek symbol on the planet in writing the language. No, I want a normal keyboard that everyone on the planet has the characters here, and then other people have other characters where I have some various things. But I'm hoping all these characters are readily available to every keyboard. Here's the German string example. Here's a U3. Size is 0 to 7 bytes and up to 7 bytes. And because it's 8 bytes or less, it'll fit in a 64-bit register, which means if I say contents of, here I have my contents of on the wrong side again, because I've been screwing around with where I think it ought to be, then these short strings would all fit in a machine register as the whole string. And one of the major, not major, one of the interesting consumers here is the database benchmarks for whatever TCH benchmarks, the high-end, expensive, big benchmarks that run on multi-mega billion-dollar machines to sell to whoever IBM sells to banks. Has one or several benchmarks where they spew out bonus pseudo-randomly generated code where you have to go find all the golds or silvers or bronze versions of different items, and they have a billion rows, and you have to go, hunt for the string gold in these giant strings, and then billions of them. So yeah, I screwed around with that performance benchmark some time ago, and having a whatever you want to call it, SIMD within a register is like an interesting payoff. So here is the SIMD
You can
version.
also use 7-bit characters and get up to nine of them in that.
I know, and I went back and forth, and I'm not there. And probably somebody, I want to make it possible that you could reasonably implement something similar, something close. The thing that you would need the compiler to do is to promise that if you take contents of a struct whose entire length fits within 64 bits, that contents of that means he just makes a value in a register. Even though you started with a reference somewhere and you said contents of, he didn't load 7 bits at a shot and shuffle and pack and unpack. No, he said, suck the whole thing up on one word and away you go. Fine. Of course, whoops. Oh, God, numlock. Thank you. Main will pick up a string thing. That was another goal for the chapter. And things I'm missing. I don't have and or. I'm going to drop my ints to I32. I've never needed 64-bit ints unless I knew I needed 64-bit ints, and it was easy enough to write I64. Very, very rare. So fine. Some performance optimization. So that's just, roadmap of what I was thinking about when I started in on this chapter, and I'm going to cut 90%, well, half of this out and save it for another chapter. Too much stuff. All right. We will once again stop share. Boom. So there's my roadmap of simple things that are in progress. Where did the week go? Well, wind and unwind, mutable arrays and nested types, and how to handle all these different things and make the decision that I'm doing the dicey, it's mutable, it's not mutable. You can have both. But
the mutability,
yeah,
the mutability question actually brought to mind, since there was mention of Rust's borrowing system there. Rust has this kind of interesting thing where when you declare a local variable, you declare it either like when you declare it, it is immutable by default, and you need to use the mute keyword to say that this local variable is mutable. And they're actually thinking of they're actually thinking of getting rid of that.
Okay, why?
Because the borrow checker is actually sufficient to guarantee that a local variable will never ever, like, you can't F it up. You can't, like, they're basically, they're always safe to mutate, and the only thing that the extra mute keyword there does is it adds a couple of letters that you need to type, which tends to get kind of annoying. And aside from that, it's just like a little bit of declaration, like sugar, that you can read and say, see, okay, this is going to be mutated. But on the other hand, like, doesn't really matter too much.
Yeah, for local variables, I'm with you. I did it for completeness sake, but for local variables, it makes any real difference. In my coding style, the count of times I've used the final keyword on a local variable, I can count on one finger kind of thing. The scope is small. You just observe that it gets set once.
I never understood that fetish of putting final on local variables.
Since when do
you just randomly like start changing variables? Like, I'm just gonna put a value in this variable and hope nothing breaks. Who does that?
So
I don't understand.
I can be argued totally that local variables are always mutable. And it does free up a little bit of syntax for declaring how you do deep or mutable or not for the references.
Yeah, I mean, the only register that should ever be immutable is the 0reg, right?
Fine.
I do use
languages like
I do use const pretty often in C++, and when it comes up, it's in OpenMP, because if you have OpenMP, you can parallelize loops, and then you can declare some of the variables to be shared or private, and you can share the variables that have been const, because the OpenMP transformation passed in the compiler knows they are not going to be changed. So const for local variables does have a meaning. And I often in numerical codes have examples where most of the things are immutable. It's only this one loop counter and this one array I'm writing to that are mutating. So I would like to call attention to them, and all the other arrays I'm gonna be reading, and all the local variables like different offsets that I start reading the arrays from are also gonna be immutable.
Right.
So to me,
You are writing assembly code so that a C compiler can compile your C code to assembly code. That
well,
is,
no, that's
I
complete
understand
nonsense.
what you're.
That's complete
I
nonsense because
understand
you
what
do
you're
not have.
saying,
No, I
but
think
you
that's
know,
sorry, Cameron, but I think that's nonsense because you don't have immutability and mutability in the assembly level. It's exactly this higher level of abstraction that takes you away from the concerns of assembly programmer and allows the compiler to do the thinking and work for you.
no,
So it's
you're tricking
exactly
the compiler into doing something.
no, that's a level of abstraction that is well defined. Immutability has been in programming languages for exactly this reason, to express yourself and don't and have the compiler do the bookkeeping for you. If you have everything that is mutable, then you have a zoop like a traditional assembly programmer has. So it's exactly the opposite way. It's exactly opposite.
Yeah, I'm with you, Matt.
If you're not changing the variable, it's immutable. The compiler should be able to tell that, and I'll die on this hill.
Well, everything immutable by default makes sense to me.
So the local variables are going to be only locally updated, and there's no multi-threaded behavior there in the normal world. When I did H2O with big auto parallelizing, it was still that way because the individual Java things. Under OpenMP, it's not clear to me that that syntax holds. If I declare a variable in OpenMP as a local variable, is it still considered multi-threaded mutable, Matt?
So
What are the
no,
rules?
no, and the constant helps even in function arguments, which is what people are surprised. Like if you have a function that takes an int, it actually makes a difference if it takes constant int. And I'm talking just about int, not even a pointer to int or reference to int, literal int. It actually makes a difference whether you have a const in the argument. Because you know then it's going to be safe to be shared if it's a const value. So
But
even
you
in
know, if
So
the compiler can't figure that out, there's a serious problem.
and I would argue that there is a certain level of problematicism problems with trying to figure that out in a language where like constant casting and so on is possible. Because if you don't declare your local variable as const and you give like a const pointer to some other function to it,
No.
that function can mutate your local variable
Right,
now.
right. So here you
So
brought up I made a pointer to what would otherwise be a stack-based value, and I'm handing it off. And now immediately you open
yeah,
up a whole new can of worms. The,
yeah.
the reference can of worms.
I think you need
yeah.
something like a
So
borrow checker to actually prove that this is safe, because if you want
Right.
the compiler to figure this out, the compiler has to figure out is it safe for concurrency sharing. And
Yeah.
that
yeah,
requires a better type system than most languages that are
yeah.
not Rust have.
And
Yeah,
this
well,
is
it's
precisely
even
why in
worse in
Rust
that.
they're thinking of removing it because it actually
Yeah.
can. There you can actually prove it.
It's even worse in C though, because you can take the reference of a different variable, treat it as a byte array, and now just go to town. Like, so there's no possible checker for C. We know this. You can get 80% of the way there easily. You can get 90% of the way there okay, but you can never get to 100%, even if you mark it const. So yeah,
Suppose you start with C syntax, but you agree that you're not ever going to cheat on you pass in the dash strict or whatever. You're not going to cheat on casting away and all that kind of shit. Is it now interesting to const a local variable or not? A local
yeah,
variable, not an argument.
on an 8086, sure. On a
No,
modern CPU, no,
no.
it's
So yes, I'm
effectively it's what
asking.
Java calls effectively final. The compiler looks and says nobody's fucking with this variable, it's final.
And so you can pass it in as a default into a lambda. And there are plenty of times when the Java C will say no, and I have to manually copy it from an int to a final int to get Java C's compiler to let me use it in an inside of a lambda. And I claim that's a kind of a failure, not of the optimizer, but of the Java C, the strength available to the Java C compiler, which is not very strong in type
I,
system
I
things.
just I just don't get the fetish about writing code to try to trick the compiler into doing what the compiler should know to do anyway. It just drives me nuts.
So I think
I,
Matt's not doing that though. This is the deal. As soon as you
but he
say,
is. He instead of saying int for an incoming variable in a function, he has to say constant. Otherwise, the compiler won't do the right thing. Even though nobody writes to that variable, it still
Well,
has to be marked
but again,
constant.
to prove nobody writes the red variable, you need to have some global reasoning or a type system like Rust
But
does.
you can't prove it with const. That's the point, because I can take the address of the previous variable and go to the ninth byte of that byte array that I
Oh,
just,
that's fine. Provenance, pointer provenance. You can fully assume and you definitely assume undefined behavior if you have broken aliasing rules. So if you have an address of one variable and you form a pointer to another, compiler is free to go to town and compilers do definitely do
right, right.
but
optimize.
how does const help in any way is what I'm asking.
It's basically like a promise that you, the programmer, is not going to modify that value. And again, if you were to infer
Right.
that, I think you have to infer the sharing being safe. And the sharing being safe under concurrency is not easy to infer.
But the point is, if it's a local variable and nobody's writing to that local variable, what's the difference between calling it const and not?
I think part of the confusion here is local variable versus pass by reference values, which have the constant niche. I think, yes, a local variable can tell that no one's writing to it because in Java-like languages, you just can't take that address of that local variable. It is not a thing. There's no pointer to it. So there's no pointer provenance games going on. If you go to a version of C where you cannot take the address of a local variable, then again, I think you're safe there. You can tell there's no one writing to it.
Yeah, as a reader, I do like this immutability, but honestly, I already prefer immutability by default. So then you don't have to write const or you don't have to write final because it's there everywhere. And that one special variable that is a counter and that one special array that I'm writing to, I'm fine to put mute on in front of this just to
Yeah.
indicate that's the thing that's mutating. So my most preferred version is immutability by default and call out the things that you mutate, including local variables.
That's a reasonable point. Yep.
That sounds counter to what you just said. Fine.
Well, so I just want to point out this paper I put in the links. So it's called Mutable Variables and Reference Types, L Values Demystified and Deprecated.
Oh, I think I'm just reading this thing.
Yeah, so okay, so I honestly don't think it's written that well. But like what it basically says is, I mean, it starts out fine. So like there's two traditions for dealing with mutability. One is sort of Fortran algol, that you have pretty much everything is a mutable variable. You have all the values are stored in mutable variables, and then you can take their address. And you can also declare them const. And then in contrast, in like this ML Haskell kind of tradition, you have everything is immutable by default.
Yes.
And then if you want it to be mutable, you put it in this explicit reference type. And then you can mutate the reference type through these special operations.
Yeah, I was just reading this and I've bookmarked this as one of my, good old favorites explaining the differences between the two and why there's a confusion.
Yeah, and I think the most interesting part is that they are pretty much equivalent. Like you can translate Fortran style to ML style and vice versa. But like the translation is not at all obvious. And that's sort of where you get the title, is you say that you don't have anything like an L value. What you have is you have a reference type in disguise. And if you take the address all the time, then magically you'll find out that your reference types are there and you just weren't noticing them in the C code.
Right. Yes. I think he did a good job of explaining why the confusion, because one looks, they secretly everywhere in C, you have a reference, you just don't know it. It's called an L value. And now if you think of it as everything is an L value all the time, and then you're doing contents of and storing into, and then you go over to the camel size and say, I have references everywhere, you get the same behavior with the same syntax, but there is definitely a weird translation because the defaults are different in the languages.
Yeah, so that was one of the things I wanted to mention was just for when you're working on chapter 22, like I mean, obviously, like you've designed the surface syntax, and so it's like you have the surface syntax you want, and I mean, sort of fixed, I guess, as you want that certain C style language. But like internally, I think it makes a lot of sense to design a compiler around this kind of ML immutable style stuff with immutable boxed reference types.
If I'm designing a compiler around it,
yeah,
I'm trying to make it obvious when you have a reference and when you don't.
Yes. So
you can't take the address of a local variable in simple. So simple local variables are stackable directly.
Yeah, I mean, so because what has been demonstrated numerous times in like the C++ language is that it's very hard to think about L values. So
yes,
that goes back to even the Christopher Strachey's paper, Fundamental Concepts of Programming Languages, which introduced the notion of L value and R value. And right in the section on the assignment, he pointed out we need those two concepts because L value is like a location value, which is an entirely different thing. So I believe it was the Algol programming language where it arose.
This sounds like another useful link to read in your spare time or something.
Yeah, so he does actually, I mean, he discusses, he basically, this Oakman guy that I was referencing, so like he basically says, well, you could actually don't need the concept of L values. You just need to carefully define the translations. So,
Right, right, right.
but
One of the fun things came out of that paper.
yeah,
I'm good to have a link to the other one, just to compare and contrast, because some of these are very old ideas. Like this paper
yeah,
itself is not new.
yeah. I think it might be
Oh, this
somewhere
was
in
this
there.
was last updated, but I grabbed this link well before here.
Yeah.
No, he's not going to give me an easy date. I know he's coming from older things, so that's 22, and that's no, that's a text version. Okay, I don't have an easy X. I swear I've seen this from a long time ago. Fine, maybe I haven't. Maybe it is brand new.
And if you're talking the paper by Strachey, that was 1967, Fundamental Concepts in Programming Languages. If you just Google that, that should be first result.
I can't spell that name though.
Fundamental Concepts in Programming Languages. Just
Fundamental concepts.
yeah,
I'll get
that's
this.
enough.
Books, basics.
Use double quotes.
Yeah.
That fixes the. That is not a good search engine. Try on Google.
Yeah, I'll try Google.
I'm impressed that it has no results. I have to say.
Okay, so I found a paper called "The Main Features of CPL" by Strachey, and
Yeah,
that
that's the one.
Here it is.
That's
Okay.
the
yeah,
one. Yeah.
DePaul
And
University.
it also has Wikipedia page
Oh, it
because
does. Let me
it's
see
a
if I can get
pretty
to
famous
Wikipedia
paper.
first.
So originally in 1967 and then reprinted in 2000. That introduces all of those terms like L value, right value, referential transparency,
Okay.
parametric polymorphism even comes from that paper.
Yeah, fine.
Okay, next topic.
Yeah.
all
So,
right.
oh yeah, go ahead,
You
Alan.
can go. No.
Go, go, go.
I have this presentation to give, which I don't, will take a while. So you first.
Uh, okay, my quick question is if we extend the const game, what about const expression and comptime in Zik? Does
Oh,
simple, I believe some of the machinery is there to
yeah.
reduce the expression to a value, but you have to make it mandatory in the source code for the
Right.
compiler to do that. So
Right. And I don't. I've thought about this. This is the Joe Blow and Jai, whatever. Right. This is. And I did
yeah,
like all
yeah.
kind of shit and four things I did long ago, and a lot of it.
Interestingly, going back to the exam of the Cameron saying, why should we tell this to the compiler? Shouldn't compiler figure this out? Well, there is actually an option in GCC, f implicit constexpr, that figures out which C++ function should be constexpr and evaluatable at compile time. So maybe you should
Wait.
have the compiler
Yeah.
infer this.
Which has some fun side effects, by the way, because sometimes it slows the compiler down from, 2 seconds to 3 hours or whatever. Because some
Well,
of the
right.
Well, that and the semantics of floating point. Maybe you wanted this to execute on a GPU, which has very specific floating point implementation, but now you're going to evaluate the function at compiler time, and the compiler runs on x86 CPU. Are you sure you're going to get the exact same number as the result?
Well, okay. So those are almost two different things. So one is, what is the sloppiness allowed on the floating point? So I'm going to say right now the F64 I have is IEEE 754. So that's the limit of the sloppiness. So the next thing is that, is there a desire to have a looser FP spec that the GPUs are going to use that are totally usable by a GPU? And every neural net AI startup on the planet is going there. So is it time for subword, FP4, FP8 things or with different rules? Okay, fine. And then there's one that says, I want the compiler to evaluate automatically at compile time, which he does for many, many things, But right now, the compilers I write and most ones I see stop when they have unknown trip count loops. And then as soon as I say go ahead and force the evaluation, it can entirely be the case that the loop trip count is into bajillions and heat death of the universe when the compiler comes back on you.
But that should be acceptable if you
Well,
aim
but you
to.
have to ask for it.
Yes, you
I'm
have
going
to
to
have the
say
source.
that there is a need for a constexpr
Yeah.
as a compiler hint that says burn all the cycles you want, force this thing to a constant.
But right
And at that point, the compiler might as well be a full runtime that has an internal JIT, and he JITs your code and runs it on the GPU and emits x86 to go make those loops go fast and everything else. I mean, he can be meta all the way.
Yeah. Yes.
And I
Right
know
now,
that Joe Blow's gaming, he plays games where he builds various things and he goes to third-party tools at compile time to go
yeah.
boil down an image to some wad of bits or whatever he's going to do, an
Yes.
animation sequence, and then
Yeah.
suck that in as a pre-baked thing, but he considers that a compile step as opposed to application of separate tool for separate files, which is what a make system normally, a build system normally would deal with.
Right now, simple will follow the chain of const and evaluate them. It's almost there. So, but you have to have the source distinction that it must reduce to a value, and that would
And
be
it's an
for
error if
function.
it doesn't as well.
Yeah,
Yeah,
and
yeah.
error if it doesn't, and that
Right.
would be maybe for functions most useful. So you can compile and evaluate some expression.
At the moment, if I come to a constant valued function pointer and I see any reason to inline it and it gets inlined, it will keep on folding and it might just completely eat up and become a constant like you expect.
Yes. Yeah.
But every compiler on the planet will do this. It's the force it in case like the inlining heuristic would say, I'm not normally going to inline this thing, but you want full evaluation. So not partial evaluation, but full evaluation. How do I do that? Simple has an evaluator. I could leave that in with the compiler and he could say at some point, I'm going to stop and switch over to the bytecode interpreter, basically.
Yeah, but all of the things it work with, it has to be const. It has to be known at
It has to
compile.
boil down to a constant, sure.
Yes, yeah, sure. Yeah.
So then you get things like, the FP1 for F64 versus GPU, I think is definable in a reasonable way to say, this is the GPU's allowed FP syntax or not. But then there's like, hey, I want to suck in this icon or image file as an array of bytes by the compiler, and it goes go into the constant pool, and I'll do things with it. But that means I went to the local disk and I pulled up a file at compile time and declared this part of my syntax. Is that a thing? How about I asked at compile time for the number of CPUs to gate how much parallelism is going to be available when I run on some other platform. Hey, I'm on this machine here. It's got 20. It's a compile time constant if I'm compiling on the local machine
But
and
I
I
believe
declare
that would
that I
be
can get at it.
that would be
Right.
logical if you designate it to be to take the number of CPUs on what you're compiling. So you shouldn't expect to know the next platform it will run on.
Well, that's what I'm pointing out is that as soon as you say, const here, I'm asking, is the number of CPUs on my current machine a compile time constant? At compile time on my machine, I'm compiling on my machine. It is certainly a constant.
Yes. Yeah.
If I then use that to get a constant out, I guess maybe it doesn't matter. But if I were to use that to say something about how many threads I should fork on the machine where I get loaded onto, it's not a constant. It's whatever the hardware has.
And even for pure numeric computation with pure values, even if you specify you have IEEE 754, you can still call a library function like sine or cosine, and probably CPU implementation for the sine is not going to use the same algorithm as the GPU implementation for the sine, even for IEEE 754 double precision floating point number. So
I would claim that would be a bug.
Well, no, because it's different implementations are optimal on CPU and different implementations are optimal on GPU.
That's not what I'm saying. I'm saying the spec is very clear what sine means.
Well,
There is
no.
no
So
there is no slot.
IEEE 754 only specifies fundamental arithmetic operations and scalar types. It doesn't actually specify the precision of the trigonometric functions.
That's about trig
There's-
functions. Okay, the Java implementation, the Java spec clearly gives a spec which is the same as IEEE default spec of less than one op in all cases.
Yeah, nowadays C compilers disagree with each other, or C library implementations, even between client and GCC,
Interesting.
do not agree.
Okay. You could declare that as a for a bunch of those things I say you could declare that as this is what the implementation will give you. And then if you wanted to do it earlier or later, compile time or on future execution on future hardware, it would be a bug on the future hardware if it didn't match your compiler's
And how
execution.
much does it actually matter is another question.
You know, it either matters very little or everything.
There are customers that require bit level reproducibility for floating point numbers.
Yeah,
Yes.
but that's what I'm saying. It either matters not at all or completely.
Just, I mean, even in the games, if you have multiplayer game is essentially a physics simulation that has to be consistent across different devices. That's what it is. So you would have divergent gameplay between one player on
Right. So
one CPU and another.
you're arguing here for comp time specifically, because the more you do at comp time, the more it'll be the same across them all.
Oh, that's a
Yeah,
good point.
but you have to bring the implementations of what you're using to comptime too. So ideally, you should have one mathematics library that then you would be used to evaluated comptime.
Right.
And it has to be somehow reproducible with the one at runtime, and that part may be non-trivial because currently the runtime implementations disagree with each other.
I was actually going to go for missile controllers as opposed to online gaming, but maybe online gaming is more relevant. And I guess the other one, modern, would be drone stability controllers.
And even any large-scale simulation today in physics research, if you run on something like 100,000 cores, some of them will be failing from time to time. You have to do live migration. If you do live migration, you don't want to lose precision.
Yes.
Yeah, but again, you're arguing for doing more at comp time to get more stability.
Yeah.
Well, yes, but unfortunately, those simulations often do have runtime data.
Yeah. But right. But that's that's the implementation on the large simulation device. When you detect a failure, how do you roll back? Where's the safe point that you went back to, the checkpoint you went back to, and then you rolled forward? Did you screw up any of the math along the way?
Because what I can tell you is all the ML workloads, which is 99% of GPU usage now, and it's 99% of floating point usage now, they don't give a rat's ass about precision at all. I mean,
Right.
like, yeah.
Okay, but wait. You can't
0.7
say
is not a number.
no, Cameron. You can't say because 99% of the people are using I don't fuck math on GPUs doesn't mean there are no. I need it perfectly precise. Like I want my bridges to not fall
Yep.
down. So if a civil engineer tells me you need to be IEEE 74 compliant or this bridge will fall down because we don't know, okay, that's worth something. So I'm just saying there is a market, an interesting one for.
But I don't
perfect.
think I don't think that 64-bit precision floating point being off by one, what is it? One
You
mop,
often
one,
want blah, 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 blah. Lowest precision.
one,
What
yeah,
is
one alp.
you?
Being off by one alp is not going to cause a bridge to crash because that's silliness. But
No,
I do
But
understand there are cases
no,
where you want 100%
it's not.
reproducibility, and that I get it.
It's not that the one op in the last bit of the final calculation matters. It's the one op in the hot inner loop of some stress tensor math calculation for how the stresses flow that accumulates over millions of iterations while you're dealing, while you're working through the
Right, but if that produces
loading.
a big enough error, then
It,
your
it,
code is
it
wrong.
does. It's quick. I did this with H2O. You could play those same games on H2O, and we did all the time. The obvious one was the here is a collection of a billion things. Give me the average. And one of the numbers was a billion times bigger than the other billion numbers. And if you added up the billion little things, they added up to a billion. You added the one big number, you got 2 billion. Divide by 2, you got a billion. Yeah, sounds good. If you start with the 1 billion number and you add a billion little things, they all round off to 0. errors, threw them away. The sum totals to 1 billion. You take average, so you divide it, and suddenly the size is minuscule. It's a huge error. So everybody who does math over large counts of numbers ends up hitting the ULP issue. And there are algorithms which are numerically stable under large counts of things, which H2O had to go implement. The default go compute the mean by adding everything up and dividing by the count would work great if you had normally distributed numbers and would suck if you had outliers. And it was very obviously suck. These things happen today in real life, doing real math for people doing fucking interesting science and med and insurance companies and shit. People hit this shit. So yes, the AI folks doing neural nets, they want sloppy fast, and they want super fast, and super sloppy's fine. That's great for them, but that's not how you want your bridges built.
I got bad news. I'm guessing in a couple of years, all bridges will be built by AI.
Yes, suck.
Just don't drive to Tacoma.
But I'm walking everywhere. I'm ready for the apocalypse. I'm going to get my garden going.
You ready for the Tacoma Narrows version 2?
Exactly. Mostly the county won't pave the roads around here, so they're all falling off the mountain anyhow. Few bridges around here. There are some bridges around here, but they're old bridges, so they're not going to hit the new bridge issues. Fine. I guess we're watching for the next great blunder. Holy crap. All right. Enough for ULP math. Tacoma's Narrows, yes. Well, that was a interesting learning for every civil engineer everywhere. ULP, ULP.
Oh.
I'm talking to, yes. Units of least precision or last precision, least precision.
Last place.
Yeah. So Allan.
Yes.
Yeah.
Oh, far away.
Yeah.
Will you
So
present?
let's see.
You have
Yeah,
slides,
so if
right?
I can, yeah, so the Allan Gardner that has an image, apparently, if you can give that one sharing permission, that would.
Right. Hang on.
And I did try this offline, and it seemed to work in like
Okay,
a
try
test
now.
chat. All right. Let's see. System window capture. There.
System window cache error? No.
Let's see.
No.
Did that work? Is it working?
I have a blank.
Looks like night mode to me.
Yeah, blank
Is
screen.
it working? Let's see. I mean, it's
Hey,
doing
There we go.
worked.
There we go.
Oh, got
Aha.
something.
Okay, and then let's.
Cuts, continuations,
so
and
let's
choice.
see.
Oh dear.
Yes. So I called it C4 because I looked and like apparently that name wasn't taken. I was amazed.
There.
Yeah.
There's a guy that did something called
C3,
C3, and there's a guy that did something called C2, language called
So
C2.
C4 should detonate or something. I don't know.
Yes.
Blows
So
up his face.
this
All
is
right,
like
go.
yes. All right. So the problem today is compilers. They have fragmented phases. They have a rigid evaluation strategy, and their optimizations are discontinuous.
I don't know what
And
that
then
means.
there's no perfect mode. So if you want like the perfectly fastest thing, you can't get it.
That's
the
because
idea
you
is
couldn't
we'll
get
build.
it if you had the perfect flag because of heat death of the universe. You'll never get there.
Well,
But it's fine.
okay, we'll get to that. So,
Okay.
so the goal is to build a new compiler, first principles, optimal, flexible, lots of profiling stuff, and verifiably correct, which I guess makes it really hard to do. So, let's see what we've learned from prior systems. So VA, we learned that effects are tricky. Unison, we learned to do branch and bound.
That's
GHC,
the folks who did perfect scheduling and register allocation together.
Yes.
Okay.
Okay. And then GHC, purity, prologue, non-determinism, hotspot, real-world profiling, LVM, a strong IR, and then Daphne is like the one programming language that actually does a little bit of static verification. Okay. So yeah, so what will make C4 different? We'll have this logical IR that I've spent far too long designing. We'll have profile guided specialization everywhere, and we'll have partial evaluation. Okay. How will I implement it? I'll read the papers. There's far too many papers that I've read, so I could just pull these out all day long.
Yeah, don't.
Hard questions that, I was hoping Cliff would ask, but you haven't asked any questions yet. Why not extend something else? Well, they don't work. What makes this technically feasible? Well, I don't know. Well, I was going to say language models, but the language
There are
model
some,
wrote the
yeah, things have happened in the
explanation.
last 20 years that make a change here. Yeah.
Yes. What if verification is too slow? Well, we have failover, and we don't assume it's perfect. We just assume that it sometimes gives good
Sometimes
answers.
verifiable. Okay.
Yes. How is memory management practical without garbage collection? That's probably the biggest question.
That's
And the answer
Rust.
is I don't actually know it's possible, but there are these papers that say it might be. So I think it's worth exploring.
Isn't this just Rust? I'm not saying just
Well,
Rust, but Rust shows
no, well,
things.
yes, and so Rust is kind of like an example that something is possible, and the
Yeah.
question is how far can you push it? So,
Sure.
yes, so this is the architecture that I came up with. You have the logical
Cute
IR.
little icons too.
Yes, yes, that was like the I used like these AI diagram generator, and it just stuck in the icons by itself. So, um, yeah, so that's sort of the flow is you have the logical IR, you have the control flow graph, and then you have the machine code, and then you have these two stages that,
Wait,
you know.
question. Isn't C of nodes about not having control flow graph? Why do you have C of nodes style CFG? What is that?
Well,
IR.
so I mean, Sea of Nodes does have effects, so it does have a control flow. So it's not like it's, free of control.
Right. It does.
Yeah,
So
yeah.
you
I
have
mean,
control nodes. So you have control nodes in the style of C of nodes.
Yeah.
yeah,
IR? Okay.
yeah,
Yeah. And
yeah.
you can make them do parallel things and you can do bulk matrix multiply array. You can do bulk operators and shit, but there's definitely control flow and effects.
Yeah. And then the other thing is we have this dynamic choice thing going on. So like every time it makes a choice, it records it. And so then it can go back later and use the profiling data and say, well, maybe I should look more closely at this choice. So
In
yeah,
C2, we call those heroic optimizations.
yeah.
I'm going to guess that you're never going to pass a null here in, so I'm going to code in the null by taking a seg-v, and then, ooh, I took a seg-v. Oh, maybe this was a bad choice. Let me go rethink that choice.
Yeah.
But if you didn't seg-v, then hey, I didn't have to put in a null check, or I got one for free from the hardware. Yeah.
Okay. Heroic optimizations. So yeah, so the plan is sort of this middle
Middle
out build
out.
strategy. Yes, I don't know if you're familiar with middle out. It comes from the show Silicon Valley.
No,
I won't
I'm
say more
familiar
than
with the
that.
concept. I'm not claiming.
So you start with the control flow graph, and then you sort of go down into generating machine code, and then you go up with generating the logical IR and compiling to the control flow. And I said 2 years as the timeline, which
You're getting
is
more realistic in your designs and estimates here.
yes. Well, or I should more say that ChatGPT is.
That could be ChatGPT's getting more realistic too.
So, and yeah, so it's like, yeah, let's maybe get the compilers right this time. Not that anyone else has gotten them wrong necessarily, but we can be more right this time.
Right.
Yeah, and I think, yeah, that's it. So, let me see how I stop my share.
So what's the difference between logical IR and the CFG IR? What concepts does the logical IR express?
Well, let's see. What concepts does the logical IR express? So, well, let's see. So the main thing is that it's pure. So like there is no control in the logical IR. So that's very hard to express.
No effects or no control.
Well, there's so yeah, so essentially you're writing like an imperative program as a pure value. So like imagine you're generating like a straight for the print hello world example. you're generating like a value that is essentially print hello world and exit, and that is the program per
But
se. So
how will you encode the choice? If or case or match or something?
what do you mean choice?
The choice of multiple possible paths of if
Oh,
else.
well, so that's like an
Cameron.
explicit choice. So you say like, I don't know what I want to compile. So just figure out between this three ways to print which way to print I want. And
Hmm.
so, something like that. And so then, it'll just, so when it compiles it, it'll pick one and then it'll maybe investigate the others as well,
But
depending on how things compile.
what if the choice is a runtime decision, if else or something?
Well,
Go.
that's where you have like, this whole thing with like safe points and on stack replacement and all that, JIT stuff is like you actually can like put the choices through all the way and like, reinvestigate them depending on how the program runs at runtime.
Hmm.
Yeah. So like the example I have is like, maybe you have a tree map versus a hash map, right? And so like you don't know which one you want, and so you leave that as a choice point. And then like maybe it'll like dynamically, test both and decide which one is the better data structure for your use case.
That one could be done entirely without actually invoking any sort of, you can do that at the Java level. You could have a Java container class that just counted uses of different things.
Okay, but what if the choice
Switched under the
depends
hood.
on a runtime value? So there's comes something from the network, and if it's below 6, then this way, and below upper than 6, then that way. So how
Well,
would
that's
it?
where, so you use profiling data to figure out which choice you want. So like it'll be running both in parallel and like, flipping back like 50% of the time and then like, figure out which one is better
So
for.
if I understood correctly, you will allow the control flow like if else statements, but you always will evaluate them, or you always will untangle them, so they are no choice. That would be made by the runtime via profiling or something.
Yeah, so I mean, there's like a sort of this execution monitor sort of thing that figures out how the program is running and monitors the profile statistics and says like, well, let's try this strategy next. And so,
I mean, Hotspot has this as a version, but any dynamic runtime, V8, all those JavaScripty things, you count in the default execution strategy, and you exceed some threshold, and then you ask, is it time to JIT? And that immediately gives you, 2 to 3, however many tiers, compilation strategies is one of the things. The garbage collector also has shit going on where he counts lifetime of things and time to death of various classes, time to age out, and should I promote you to old gen or keeping the young gen, and then one more GC cycle later you'll die, and I don't have to promote you and deal with it that way. So these things, there are
yeah,
instances of these things all over the place.
yeah, and so my impression is that you have multiple compiler strategies, but like you don't necessarily have that at like, a source code level. So like, for example, I was reading, I think it was the GNU multi-precision library, right? Or they have like, or maybe it was the BLOS library. I don't remember. It was some numerical library, right? And so like I think they had like three different ways to multiply integers together, right? There was like a just a normal like straight standard way. There was a slightly faster way that used like a little bit of shuffling around, and then there was like a really kind of complicated way using Fourier transforms or something, and then it was really fast for like gigantic numbers, but not for like medium-sized numbers. And so what they have is they have these like magic constants in there that like when the number gets this size, we switch to this strategy. When the number gets to this size, we switch to this strategy. And to me, it just seems like, I don't want magic constants in my source code. I want to tell the execution engine,
You,
like,
you're gonna have
these are the strategies, figure out which one is optimal at which size.
you're gonna
So,
have a bajillion magic constants in your source code no matter what you do.
yeah.
You could still say I'm also going to do things where I measure time and decide to change things or not or whatever. But
Yeah, but I do think these magic constants are going to be dependent on like the specific CPU architecture and stuff. They're not going to be like,
yeah,
I mean, they can find, reasonable values for, a variety of architectures, but they're going to be architecture dependent. So,
the architecture wars are almost died down in the CPU space. It's all GPUs. The AI
yeah.
chips have architecture games going
You
on.
can still have something workload dependent, like I would look into the research on self-tuning databases because they essentially try to do what you're doing for programming languages, but for databases. Like there's those hundreds of configuration constants when you configure a database. And the idea is that they should be able to adapt themselves to the workloads because sometimes you switch between more analytics workloads to more transaction workloads in one database, which sounds crazy, but some people do it. And then different strategies and different execution strategies change even if you had something that used to work, it may stop working. So that may be interesting thing to look at.
Okay. Oh yeah, I don't know. There's a systematic review that they did last year, so I'll put that in the links.
One more paper to read.
Yeah.
Just one more. Just one more. Same as it was a year ago. I'm all looking forward to seeing progress. Slides are easy.
Yeah,
Code
I'm
is not
not.
cheap.
I
Slides are
mean, I
cheap.
put together the slides, but I don't really have that much interest in like working on a huge compiler project right now.
Okay. All right, fine. You got to figure out what you're doing with your life.
Yeah.
It's all good. I got to figure out what I'm doing with my life. So there you go. You think at this age I know what's going on, but no, I got to go sort myself out
So,
again.
Cliff, when you and I grow up, we should write computer games.
I've been wanting to write a computer game since I was young, and it just never was the right time. And I have all kinds of
Yeah.
fun things in my head for writing a computer game.
My next startup will be computer games.
All right, I'm in. Call me when you're good to go. I'm there.
You should just ask Jonathan Blow if he has a position open.
Maybe.
I don't think he scales to a team larger than one.
So if he and I were to get together, I highly suspect it would go one of two ways really quickly. It would work out fabulous, or there'd be knives and knives at dawn, or drawn guns at dawn, pistols at dawn. Yeah, wouldn't take long. Fine. Oh, all right. I'm going to call it. I got another errand to run down the mountain today. Yet another one. Where'd the time go this week? Well, all kinds of things happened that unrelated to anything that had to be dealt with. So stuff needs to get solved. All right. Yeah, this was a good round. Good talk. And I guess we'll hopefully see people next week. All right.
See you.
Bye-bye.
Bye.